Hi everyone. We're going to talk about absolute value inequalities today. We've been talking a lot about inequalities. That's our main thing from Module 6. Now we're going to add in absolute value, which we learned earlier in the year. So let me remind you of something very important about absolute value equations that we solved earlier. One of the most important things about absolute value equations is realizing they're always going to have two answers. You're going to have one for the positive version and one for the negative version of that number. Now we're going to have something real similar for inequalities today, but instead of two completely separate equations, we're going to end up with what we just talked about in the last section, and that's a compound inequality. It could be the and version, it could be the or version. So to kind of show you where this is coming from, I want you to think of absolute value as distance on a number line. And what I mean by that, it's real good to start thinking of absolute value as distance in one of two directions. So for example, if I give you the absolute value inequality and I said the absolute value of x is less than 4, what that could be thought of is from 0, I am moving less than 4 spaces in either direction. I might move up to 4 spaces in the positive direction, but I also might move up to 4 spaces in the negative direction. So the way I would write that as a compound, or the way I would graph that is like this. Right in the middle here, this is 0, and I said I could move up to 4 spaces to the right, or I could move up to 4 spaces to the left, which would actually be -4 on my number line. So that's how I graph that. That's how I drew this little graph here. I said I have all these numbers that I'm moving less than 4 spaces from 0, but it could be to the right or it could be to the left. So the way I would write that as an inequality is either x is less than 4, or, actually it's not an or, I'm sorry, it's an and. I'm saying x is less than 4 and x is greater than -4. So I would use the type of compound inequality where I just put them together. And I say -4 is less than x, and x is less than +4. Okay, now let's look at the greater than. So now let's say I said absolute value of x is greater than 4. Then what I'm saying is the distance away from 0 is more than 4 spaces. So I either went more than 4 spaces to the right or more than 4 spaces to the left. Now that would look like this, because again, here's your 0 right here. Here's 4, but I'm not going less than 4. I'm going way over here, greater than 4. And here is -4, but I'm going more than 4 spaces to the left. So I'm going way out here, -5, -10, keep going. So you can tell just by looking at the graph, this is not an and statement, this is an or statement. We learned that yesterday. We said the and statement was like my first picture from today, where you have your 2 points and you're connecting them, you're shading between them. The or statement has the 2 points and your answers are moving away from each other. So I would write this as x is less than -4 or x is greater than 4. And that's what you guys are going to have to do. Just like we did earlier, if I give you an absolute value inequality, you're going to have to write it as a compound inequality and then solve it like we did yesterday. So let's start with the less than. And I actually said this is for any less than or less than or equal to. Just like the first example I gave you, every less than or equal to for an absolute value inequality turns into the and inequality, and you can write it as the compound just using positive and negative versions of the number from the problem. So let's do an example of that, and I'll show you exactly what I mean. So let's say I ask you guys to solve and graph 2x plus absolute value of 2x plus 1 is less than or equal to 17. So you say, all right, well, this is an absolute value problem. It's a less than or equal to. Now remember, less than, we're talking about distance. So less than means you're in the middle area. You have gone less than 17 units to the right or to the left. So you're talking about this middle area here. So I'm going to set up a compound inequality. Now the first half of the question, I'm basically just going to recopy the question, but without the absolute value. 2x plus 1 is less than or equal to 17. Now the way I turn this into a compound inequality is I'm going to take the same exact sign. This was a less than or equal to. I'm going to put a less than or equal to in front of it also. Always the same sign. And then if I can go 17 spaces to the right, I can go negative 17 spaces to the left. So that's the extra part. And you recopy the problem without the absolute value, and then you add the negative version in the front and recopy the same sign you used in the problem, the same inequality. Now all of a sudden we have a question just like we did yesterday where we say, all right, well let's solve. Let's split this into 3 pieces and get that to be an x in the middle. First thing I want to get rid of is that plus 1. I'm going to use a minus 1. I'll use a minus 1 in 3 spaces, in 3 places. That cancels with that. Negative 17 minus 1 is negative 18. We'll leave the less than or equal to. I have just a 2x in the middle now. Leave the other less than or equal to. And 17 minus 1 is 16. Last step to get that x in the middle is to divide by 2. And just remember, I got 3 things to divide by 2. So for final answer here, negative 18 divided by 2 is negative 9. We have less than or equal to. In the middle, the 2's cancel and you get x. And then we have less than or equal to 16 divided by 2, which is 8. So there's my final answer. The graphing part is exactly like we did yesterday. I will draw on a number line. Let's put it, I'll put it up here. I got plenty of space. Put it up here on the white. Put 0 in the middle. My first number is positive 8, so 1, 2, 3, 4, 5, 6, 7, 8. We'll mark that right here. My second one is negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's negative 9. And I have less than or equals for both of these, so I'm going to put a closed circle on the negative 9, a closed circle on the positive 8, and I'm going to shade in everything between them for my answer. The graphing part is exactly like yesterday. What's new for today is going from here, the original question, to here, setting up that inequality, that compound inequality. You already know how to solve that and how to graph that from yesterday. All right, so let's talk about the other one. The other one was, let's say instead of a less than or a less than or equal to, you have either greater than or greater than or equal to. And remember when I showed you the example using x is less than 4 and x is greater than 4 for absolute value, the less than was the ones that's connected in the middle, that's the and. The greater than always turns into an or. So every time you do one of these with a greater than or a greater than or equal to, you're going to end up with 2 completely separate inequalities, and it's going to be the or. So equation 1, recopy the problem but without the absolute value. That's always going to be your first one. Very simple. Now for equation number 2, you're going to change 2 things. You're going to change the positive negative sign on the number, just like we did before. The last example I had a 17 on one end and a negative 17 on the other. You're going to take that number, change it to negative, but you're also going to flip the inequality. So that that greater than turns into less than, or the greater than or equal to turns into less than or equal to. So let's do an example of that, then we'll be all set for today. Solve and graph absolute value of x minus 7 is greater than 5. So you go, all right, well, whenever absolute value is greater, that's going to be an or statement, every time. Less than, and statement, greater than, or statement. Now, the first step is to create the 2 equations. My first one, just recopy the exact same question, but without the absolute value. X minus 7 is greater than 5. Now for the second one, I'll put the or in. You leave the x minus 7, but you change everything else. So instead of a greater than, I'm going to have a less than. And instead of a positive 5, I'm going to have a negative 5. Now again, once you've done that first step, once you've changed it into a compound inequality, you know what to do from yesterday. This is an or, so I'm just going to solve them separately. I can do both of them actually with the same step, just by adding 7 to both sides for this one. So I add 7 to both sides. x is greater than 12. Then, over here, I do the same thing. I add 7 to both sides. This time, we have x is less than, and that would be negative 5 plus 7 is 2. So there's my final answer. I get x is greater than 12, or x is less than 2. And for the last thing, let's see what that looks like on a number line. These are both positive numbers. Maybe I'll put my 0 over here a little since I don't really need any negatives for this one. Remember, 0 doesn't have to be in the middle. You can scale it however you want. The numbers I need are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe mark a few more points, maybe mark a few negatives even though we're not really going to use them. So this time I have x is less than 12. Oh, I'm sorry, x is greater than 12. So here's my 12, open circle because there's no or equal to. Greater than is to the right. And then I have x is less than 2. Open circle for 2, no greater than, or no equal to. Less than means shade to the left. And that's exactly what an or should like. 2 points shading away from each other. So the main concepts for today, if you have an absolute value inequality, number 1, you have to turn it into a compound inequality. Number 2, you have to do the right one. Every less than or equal to turns into an and statement, or the one where you just combine all 3 things into one. Every greater than or equal to turns into an or statement, and that's exactly like the one you're still looking at on the screen right now.